If you've been learning technology over the past few years, chances are you've heard of Git. Git is the world's preeminent source control system, and it's what powers sites like GitHub and GitLab. It's definitely one of the first and most important topics that you should be learning, especially if you intend to enter technology as a career. There are already a lot of videos out there, lots of tutorials, but they tend to focus on theory and concepts. That's why today we're going to get straight to the point with how you can start building your confidence with Git. Let's get started. The best way to get started with Git is to use Visual Studio Code. VS Code is the best editor and development environment that all the cool kids in tech use. I provided a link in the description. If you don't already have it downloaded, go ahead and download it. You can follow along with me. I'm going to open the terminal and create a new directory called Learn Git, and I'm going to open it with Visual Studio Code. If you haven't seen Visual Studio Code before, it can look a little bit intimidating. VS Code is one of a class of applications called integrated development environments. They're basically fancy text editors. Let me go over the UI. On the left-hand side, you see some icons. This is called the activity bar. Clicking on these icons will change the appearance of the sidebar, and the sidebar can actually be hidden and revealed using Control-B or by clicking the already selected activity. The main area here is called the editor. This is where files that we want to edit will appear. Let's go ahead and start a new file. I'm going to call it README. We see that it opens in this main area called the editor. And there's also a hidden pane here called the integrated terminal. By hitting Control-tilde, we can reveal it or hide it. We'll have more to do with that in a second, but this is basically the UI. First of all, let me draw your attention to this icon right here, this activity, the source control activity. I'm going to click on it and click on Initialize Repository. So what this does is it turns our directory into a Git repository. And we saw that the sidebar for source control changed appearance. And actually, if I just open the terminal real quick, I can show you that what this command did, it actually created a directory called .git. So this is what happens when you initialize a Git repository. Everything that is confusing and frustrating about Git is basically contained in here. So with that done, we can start creating our first Git repo. So we have an empty repository. Now what do we do with it? When it comes down to it, using Git involves adding and committing changes to files. We're looking at the source control activity right now, and by the way, source control is actually using Git in the background, which is why it's useful for us as a kind of GUI. Let's just run through the most basic possible workflow. We're going to add the README that we just created. It's empty, and we're going to put in a commit message, such as init. Init is a typical first commit message for a lot of repos. And we're going to hit the commit button, and that's it. Anytime you make a change, you can commit the change. Let's pretend that this repo is going to involve poetry. This is just an example topic so that we can avoid the complications involved with, different syntaxes of something that's actually computer related. This time, instead of using the GUI provided by source control, I'm going to show you how to add and commit changes from the command line. First of all, git status is what you can run to check the status of a repo. In the output, we currently see that we have a unstaged change. We can stage it by using the add subcommand. We can provide the file, although typically what will happen is that people will put the period referring to the entire directory. So this will add all new files in the directory. Now running git status, we see that the change we made is staged, meaning it's ready to be committed. We can commit by providing a message in line with the -m option, but instead of doing that, I'm not going to provide any message, and we'll see how Git will open a text editor, your default text editor actually, so that you can enter a message. I'll just put in a message saying readme edit and save it, and that's it. From the command line, adding and committing changes is almost as easy as using the GUI. So what are we doing here? What's a commit? A commit is basically a custom snapshot. The commit message we provided will help us identify the changes we made to the repo later on. We can actually produce a list or log of the changes we made by using git log. So these are the two commits that I've made. You can get a more visually pleasing and abbreviated summary of the commits that you've made to a repo using the one-line parameter. Keep in mind that a commit is not meant to memorialize every single change you make to every file, but rather, as you work on your project, you fix one issue, then another, you develop one piece, introduce a new piece. Commits can help you mark milestones. Adding and committing changes in this sort of linear way is probably enough for most personal projects. But what you'll see on larger projects, open source software repos with multiple contributors, is that more complicated workflows are used that take advantage of Git's other features. One thing that's really interesting about Git is that it allows you to time travel. As we saw, Git will keep track of changes that you make to the repo over time. But each commit is not just a snapshot, it's actually kind of a waypoint in a timeline. And you can travel back in time. Let's develop our poetry repo in a little bit more detail so I can show you. I'm going to start pasting in pieces of another poem. I'm just going to add this change, which is just the first stanza of this poem, then commit it. So it'd be as if we're kind of composing it in real time. Stanza 2, add and commit the final changes. Now that we've completed our poem, what we can actually do is we can inspect the commits that we've made by looking at git log, and the commits that I made appear here, of course. But like I said, we can return the repo to an earlier state by providing one of these IDs, which represent a snapshot, the commit, or a waypoint in our timeline, and using the checkout command. So git checkout, and then providing that hash will return the repo to the earlier state. If we look in the files, we see that Rhodes no longer has the remainder of the poem that I pasted after this commit. And we can return to the present moment by using git checkout and then providing the branch name. So what's the branch? A branch is kind of like a timeline. We can display all the current branches. I'm currently only using one by using the git branch command. We currently only have the main branch, and because I'm on the main branch, the log is actually showing me only the commits on this branch. The concept of a branch probably will be better learned if we learn how to create a new branch and how things look when we have a different branch. So let's return in time to our init commit, the first commit that we made. I'm going to hit git checkout and then provide the commit of the very first commit I made. You remember when I made that first commit, that poem that I pasted in didn't exist at all, not even as an empty file, and we see that the files in this repo have returned to that state, and even that sentence I pasted in to readme no longer appears. To create a new branch, I'm going to use the git checkout command again, but I'm going to provide the -b option, and I'm going to provide a branch name, but I'm going to follow feature branch workflow, which is kind of a more advanced Git workflow, just so I can show you how this works. I'm going to actually work on another poem. We're going to name a branch after this poem. We're going to contain those commits relevant to that poem in this branch, in this timeline. So I'm going to create a new file. I'm going to name it Ozymandias. Again, this is a different poem, and it's also famous in the English-speaking world. And if I run git status, we see that Git noticed this new file is an untracked file, and we can add it just as we did before. Now keep in mind, in the output of git status, Git tells us that we're on this new branch. We're no longer on the main branch where we had been when we added the commits relevant to the other poem. So we're on this different timeline. Changes that we stage and the commits that we make will be totally separate from the other timeline. We can get a better kind of visual understanding of what's going on by using a GUI program. I have gitg. I'm using GNOME on this installation of Fedora, And gitg will allow us to kind of visually take a look at what's going on in a way that's maybe easier to understand. So within gitg, we can see that we have two branches now. The main one, as I told you, this contains the changes that we made to the repo, the commits that are relevant to the roads poem, and we can see all the commits here as you would expect. This other branch that I'm working on is totally separate, and we see that its changes have nothing to do with the other. We can merge these timelines by using git merge. First of all, I'm going to switch back to the main branch by hitting git checkout main. Now Ozymandias will disappear and roads comes back. And we can merge the changes by using the merge command and providing the branch name. A merger of two branches is also a commit, so I need to provide a commit message. That's fine. And now when we return to gitg, we see that the branch that we had created is merged. Now the main branch reflects all the changes we made across the branches. So the whole idea of feature branch methodology can be kind of illustrated in this repo which I made. All the development happens on the develop branch, and it's only occasionally merged with the main branch. Now some of the colors look a little bit confusing, but basically what's happening is I organized each poem into its own branch. So you see when I added Ozymandias, I started a new branch. Roads had its own branch, and they're all branching off of develop. And once the work is completed on each of these feature branches, it's merged into the develop branch, and then develop then is merged into main when supposedly it's ready for release. Definitely overkill for a personal project, definitely a lot of wasted effort if you're just trying to learn how to use Git on a day-to-day basis, but this is kind of an illustration of what to aim for if you want to learn the kind of workflows that are used in software development. Probably the most important piece of Git, though, is the establishment of an upstream repository. So the whole idea of Git is that you can be working on your piece of a large project with multiple contributors, and everyone's contributions can be coordinated in an orderly manner. So the way you would do that is that, you would have your downstream repo, you'd make your changes, and then you'd push them upstream to a place like GitHub or GitLab. That's pretty much the first step for most tutorials. Start an account on GitHub, sign up on GitHub, and go from there. Rather than showing you that, I'm going to show you how you can set up your own upstream repo. Perhaps you have privacy concerns about uploading your data to a public repository. GitHub and GitLab both have the options for private repositories, but there are always security concerns. Maybe you want, you're working with private information or API keys or something like that, and maybe you don't feel necessarily comfortable uploading that, especially if you're not totally fluent with Git. So what you can do is set up a local repository as an upstream. So let me show you how we do that. We're going to be working in the terminal again. I'm going to create a new directory. This is from home. I'm just going to call it upstream. Now, the way you would initialize a Git repository from the command line is git init. This would be basically the equivalent of pressing the button, which did appear here before we initialized the Git repository in VS Code's source control activity. But instead of just using git init, we're going to add an additional option, --bear. Okay, now this initializes an empty Git repository. This looks completely different from an empty Git repository like we saw at the beginning of my video. The contents of the .git folder are no longer squirreled away in .git. They're kind of exposed, and this is what's done for an upstream repo. So now that we have that folder, we can go back to our repo, and we can add the upstream repo here from the command line. Upstream repos are conventionally named origin. I'm not sure of the history of that. In this case, we're going to specify a file. or rather a directory. And by specifying this directory with the file protocol, we can use a local upstream repo, keeping everything in-house. Now, once we do that, we can push our changes. Now it's going to ask me to set an upstream. Let me just make sure I'm on the right branch, and we're on develop. So let me actually check out main, because that's typically what would be done. You usually push main. But of course, if you're working on a particular branch, you would push that. So we're going to set the upstream to origin for main. Now the upstream contains our main branch, basically. And we can check out each individual branch and upstream it as well. But in order to show you what happens, now let me git clone, and we have to provide a separate name, so we'll just call it downstream. Now if we go to downstream, we get all the same files that were in our original repository. So we've successfully upstreamed our repo and also cloned it. Just a couple of notes. Cloning is how you would download a repo from a place like GitHub or GitLab. It's basically just downloading. And actually, typically, probably most people's experience with Git is simply using the git clone command to grab a code base that's already out there. In this case, we just used it to basically duplicate the contents of the repo that we've been setting up in this whole video. If I run an ls, now we see that even though we cloned the upstream repo, which was a bare repository, we don't see the contents of .git. We have a .git folder. So the -- bare is pretty much exclusively done for upstreams, remote repos, where you push the changes that you make. Before I let you guys go, I did want to show you this pretty nifty web-based application, kind of like a game for experimenting with Git commands and creating branches and commits and all this stuff in a graphical manner. So you see, we just punch in a few commits. We can check out C0. We can create a new branch. This is hard to see, so you see it kind of created a new branch up here. Now we can check out B1, create a new commit. We can check out B0 again, merge B1, and it's just kind of a cool way to become a little bit more acclimated with these different ways of manipulating a Git repository. In any case, I think we covered more than enough ground in this video. Gotten a little bit longer than I expected. I probably bit off a little bit more than I could chew, but I think I shared some interesting insights into Git. In any case, like, comment, and subscribe, and I'll see you guys in the next video.